So we're switching gears. Confidence intervals is what we did in the past. Now we're going to move on to significance test or hypothesis test. Those are the same interchangeable words there, okay? All right, so here we go. Back in the day, before break, a confidence interval. The goal was to estimate a true population value. Maybe you wanted to estimate the true population mean. Maybe you wanted to estimate the true population proportion of something or whatever. But that's why you were creating a confidence interval. You had no idea what the true value was. You went to the population, you took a sample, and you made a confidence interval that was your best guess for what the true value would be. Hopefully it was somewhere in your interval, right? A significance test or a hypothesis test is slightly different. A significance test, the goal is to test a claim about the true population value. So, slight difference. Instead of you going, I wonder what the true average IQ is at McKinney Boyd High School. I guess I'm going to go get a sample and make an estimate using a confidence interval. Now what it would be is someone would say, hey, did you know that the true IQ at McKinney Boyd High School is 125? And you go, bet, I'm going to prove you wrong. I'm going to go take a sample and prove to you that it's actually higher than 125. And so that's what you do. You basically take their claimed value and you go and take a sample and see if you can prove their claimed value to be true or to not be true. It's kind of like putting stats on trial. We assume that what they're claiming is true unless we can prove it wrong by doing a sample. Okay? So that's kind of the idea. All right, so you guys know Coach Brooks, right? He's right next door there. He claims to be an 80% free throw shooter. Do you guys think that he can shoot 80% free throws?
Yes.
You think he's that good at that?
Mm-hmm.
Y'all know he's a football guy, right? Okay. Did he? Oh, he did coach basketball. That is a true statement. Okay. Well, he claims to be an 80% free throw shooter, so we're going to put him to the test. But he's kind of busy right now. He's teaching a class. Whoop-de-doo. So what we're going to do is we're going to let him do this virtually. All right? So here he is. Now, Coach Brooks is an 80% free throw shooter because that's what he claims to be. He says, bro, I'm an 80% free throw shooter. That's what that line is. That's where he should be. Okay? We're going to give him 25 shots. Okay? If you watch down here, you'll be able to see if he's making it or missing it. He seems to have a little bit of a left hook, so if he misses it, that's the way it's going to go. But here we go. We're going to give him 25. Let's go. I said, let's go. There we go. Oh, dang. Yikes. All righty. Well, this isn't looking good for Coach Brooks. So there he is. There's his 25, and he has made 40% of his shots. Do you think that Coach Brooks is really an 80% free throw shooter? No, probably not, right? He only did half of what he claimed he could do. He said, I could step up there at that free throw line and make 80% of my shots. We said, okay, fine, prove it. Let's see. Give us a sample to look at, to see if you really can. He just stepped up and did 40%. Do you think he really is an 80% free throw shooter? Probably not. Okay. Well, he says, whoa. You didn't even let me warm up. Like, come on. Let me try again. Okay, fine. You know what? We'll be nice. Here you go. Here's your second attempt. Well. This is his second attempt of 25. Did Coach Brooks actually shoot 80%?
Yeah.
Now it looks like it. So his first 25 was maybe he didn't get a chance to warm up. Or maybe he, I don't know, was just having a bad run of 25. I don't know. But now do you think that he really is an 80% free throw shooter? Now the evidence seems to suggest that he really is, okay? That's how these these hypothesis tests work. Somebody makes a claim, we say, well, let's look at the evidence. Sometimes the evidence shows us that it's not what they claim. Sometimes the evidence goes, well, they're probably telling the truth. There you go, okay? So that's how these are going to work. Let me go back to that. And there's that. All right, so with our little simulation here, the first time he only made 40% of his shots. The second time he made 80% of his shots. Okay, great. Are you convinced that Coach Brooks is an 80% free throw shooter and that his claim is true? Or do you think that he makes less than his 80%? Which one do you think is the truth? Which one do you think accurately represents his true value?
A mean between them.
Maybe a mean between. So 60% maybe. Or maybe we need to, come back tomorrow and see another sample. I don't know. But at this point, we might be a little bit on the fence, okay? So it could go either way at this point. We're really not sure, okay? One of them suggests that maybe he's not. One of them suggests that looks like he's telling the truth. What could be the only two explanations for why we would get a different statistic than what the claim is? Why is it that Coach Brooks did not get 80% on that first round? There's really only two reasons for this.
Bias.
So kind of ish, maybe. What do you mean by bias, though?
Like when him saying he could do 80%, what if he was just trying to hype himself up?
Okay, so maybe he's hyping himself up, therefore meaning his claim is not exactly true. The claim is not right. He's hyping himself up. He's wanting to look better than he really is. So one explanation is the claim is false. Okay, that's one reason. Now, what could be the other reason that we don't get exactly what we expect to get? So one reason that we don't get what we expect to get is that the claim's false. The other one could be sampling variability. The claim is true, but due to sampling variability, I am going to go ahead and tell you it could also be bias. Or there's some kind of bias happening here. But due to sampling variability or some kind of bias, we get a sample value different than the claimed value. One of these two things has to be true. Either the claim is false, and they're just making crap up, or the claim is true, but due to some sampling variability or some bias or some other reason, we just kind of got a weird sample. That's the only two reasons why we would get something different than what is claimed. Now, obviously, guys, there's a third thing that could happen. The claim is here, and we get exactly what we expect. Okay, obviously that's going to happen, but this is talking about the only reason why we get something different than is claimed. Either the claim is false, or there's some crazy sampling variability happening. All right, so here's what we're going to do. Is this right? Yep. Okay. All right, so here's what happens. We need to talk about how do we talk about these claims statistically speaking. So some of you who have taken AP Bio are going to have a little PTSD right now, so I apologize, but it's going to be fine. A significance test starts with careful statements about the claims that we want to compare, and these are called hypotheses. The first one is the null hypothesis. The null hypothesis. The notation for the null hypothesis is a capital H with a little O in the subscript. A capital H with a little O in the subscript. This is the null hypothesis. This is the claimed value for the population or the status quo. Do you guys know what the status quo means?
From High School Musical.
What does it mean if I say, why does everyone say High School Musical?
Because it's in the song.
Oh, is it? Okay. All right. Okay. So status quo. What does it mean if I say that something is the status quo?
It's normal.
It basically means it's kind of what has always happened. It's not any different than what has always happened. It's kind of just the standard, if you will. Okay. So the null hypothesis is the claimed value for the population, or it's like the status quo. It's what has always been true, okay? Then you have the alternative hypothesis. Alternative hypothesis. The notation for that is a capital H with a little a in the subscript. The alternative hypothesis. This is the suspicion or hope about the claimed value. And what I basically mean by that is Coach Brooks walks in here and says, hey, I'm an 80% free throw shooter. And we have a suspicion about his claim. Maybe we think he's not as good as he says he is. Or maybe because we know he's been a basketball coach before, we think, no, bro, you're better than that. So we have a suspicion that he's better than what he claims. So our alternative hypothesis is going to be what our suspicion is, or sometimes it's our hope that we have made a change to the claimed value or the status quo. So those are our hypotheses. Any questions about those two? Super fun. All right, cool. It's exciting. All righty. The null hypothesis is always going to have the same format, okay? It's always going to have your null hypothesis, and then it's going to have whatever parameter you are talking about. What's a parameter? What's a parameter?
It's like a value where it should fall to.
It's a value that is about what?
3 standard deviations.
No. What's a parameter? Oh, I'm scared. No. No, that's an interval.
Estimate the.
Oh,
You used to I don't remember the other thing.
So it's a value that you're using to estimate what? The true population. Remember the SSPP. Population is a parameter. Sample is a statistic. Oh, man. Okay. Yeah, we're going to have to review that. All right, so you're going to have your parameter. So it's going to have to be either mu, p, or sigma. Mu, p, or sigma. Because it has to be about the population. So it has to be a mu, a p, or a sigma. Can it be the population the population median? Sure, it can be. But you're never going to see that in this class. Maybe if you take stats in college you will, but we don't do this kind of stuff for other things. All right, cool. You're going to have an equal to sign in the null hypothesis every single time. It will always have an equal to sign. Always. always equal for the null hypothesis. Because the null hypothesis is what the claimed value is equal to. Okay? And then your claimed value goes here. So, for Coach Brooks' example, for his example, I'll do that here. For his example, it would be this. The null hypothesis is that his true proportion equals 0.8. That is the null hypothesis for the Coach Brooks example. He has a claimed proportion of being an 80% free throw shooter. That's his null hypothesis. The alternative hypothesis is going to be one of these three. It's either going to be that we believe the parameter is greater than the value that was claimed. The parameter is less than the value that is claimed. What could be the third option? Well, equal is in the hypothesis.
Doesn't.
Not equal. Very good. Not equal to the value. Now, one big thing to note here is that this value here must be the same as the claimed value in the null hypothesis. Here's what I mean. Y'all, Coach Brooks is not going to walk in here and say, hey, I'm an 80% free throw shooter, and I'm going to go, no, bro, you're a 40% free throw shooter. I have to say the alternative in terms of what they claim it to be. If he claims to be 80%, I can say, no, I think you're less than the 80%. Or I think you're more than the 80%. I can't throw out a new number. It always has to be in terms of what the claim is. How do you figure out which one of these it should be? It depends on what your suspicion is or what the hope is, okay? So it depends on the direction of the suspicion or hope. What do I mean by hope? Coach Brooks says, I'm an 80% free throw shooter. I'm going to go to a camp over at, I don't know, where's a really good basketball school? Baylor, I guess, or
Houston, we want
Houston, Kansas. Okay, cool. He says, I'm going to go to a clinic at Kansas, and I'm going to get better than I already am. Then his alternative hypothesis, his hope, would be that he would have a true parameter greater than the 80% that he already is. That would be one where we're hoping to make a difference. Okay? Cool? Any questions so far? All right. A couple of quick cautions, and then we'll do a couple of examples. So, here's a couple of cautions. The hypotheses must be about parameters. Mu, P, sometimes sigma, but most of the time it's going to be mean or proportion, okay? It has to be about parameters, not about statistics. You will never, ever, ever see an X bar, a P hat, or an S sub X in a hypothesis statement. If you do, you can mark it off of the available options. So like if you're ever doing, like a multiple choice test or something, and it says which one of these hypotheses would be true, and you see an X bar or a P hat, you can just scratch that out and be like, you ain't fooling me today. Do it. So you can just scratch those out if you see X bar, P hat in your hypothesis statement. Now, are we going to take a sample Of course, we're going to take a sample to see if we have evidence to show that the claimed value is different than what it was stated. Okay. All right, and then the last thing here that I want to make sure you guys don't forget, the null hypothesis must have an equal sign. You will never have a null hypothesis that says, hey, I think that the claim is greater than 50. Nope. It has to be a single value. Has to be a single value. The null hypothesis must have an equal sign. Cool? All right, let's give it a try. Pineapples. Any of you guys like pineapples?
I love pineapple.
Pineapples are good. You should try going to Hawaii and have pineapple. Any of you had pineapple in Hawaii?
Yeah.
It's pretty different, isn't it? It's like really sweet. Okay, anyway. At the Hawaii Pineapple Company, managers are interested in the size of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. A different irrigation system was installed in this field after the growing season. Managers wondered if this change would affect the mean weight of the pineapples grown in the field this year. We're going to state appropriate hypotheses for performing a significance test, and we're going to define our parameter. Woohoo! Here we go. We need a null and an alternative hypothesis. First step is to decide, what is this problem about? Means, proportions, or something else? It's about means. We're talking about the mean weight of a pineapple. So if we're talking about mean, what notation would I use for the parameter of interest? Mu. Very good. We're going to have a mu here. Talking about a mean. Now, what symbol do I have to use here in the null hypothesis?
Equal.
An equal to sign. Okay, cool. What has been the status quo of this particular pineapple field?
31.
The mean has equaled 31 ounces. That has been the status quo. Now, they put in a different irrigation system, and they wonder if this change will affect the mean. Do they have a hope or a suspicion on a particular direction that it might go?
No,
Larger.
not equal to.
It doesn't really say that they hope it will be larger. They just wonder if it's going to be different. So we're going to use a not equal to. We don't know if this new irrigation system is going to cause our pineapples to be bigger or smaller. We're just trying to see if it makes any kind of a difference. Okay? We do have to define our parameter. So mu equals the true mean weight of pineapples in this field. Okay, guess what?
It's done.
That is it. And when we get to next week doing the state plan do conclude for these, this is pretty much the state part. This is all you would have to do for the state. There's one little thing we're going to write right before that, but we can't do that just yet. But for now, mostly this is like 75% of what you have to write for the state statement. That's it. Okay, so it's not too bad. All right, let's try one more. See what we can do. The U.S. That's okay, I can read. The U.S. Bureau of Labor Statistics estimates that 69.7% of high school graduates enroll in a college or university. Bernard has great pride in the quality of his large high school. He thinks the proportion of college-bound students is greater for last year's graduating class. We need to state the null and alternative hypothesis and define the parameter of interest. Null and alternative. All right, what's this problem about? Means, proportions, or something different?
Proportions.
This is about proportions. It literally says proportions in the problem, and we're talking about a percent. So this is going to be a P, is going to be the parameter we're using. What should we finish out the null hypothesis with? What is the P that has been the status quo or that is claimed to be true?
69.7.
Yeah, so the true proportion is claimed to be 0.697. That's what the U.S. Bureau of Labor Statistics says it is for all high school graduates, okay? But Mr. Bernard, at his fancy-dancy little school, big, large high school, what is he thinking?
It's larger.
He thinks that at his school, it's greater than 0.697. Now, we do need to define this P, okay? What does this P actually represent?
True proportion of high school students that graduate.
Okay, you're close. You're really, really close. P is the true proportion. This problem is talking about basically high school graduates that enroll in college. So students that go to college after high school. So true proportion of college after high school. But here's the question. Is this for the U.S. or is this problem for a specific high school?
Oh, specifically.
This is actually, we're talking about Bernard's high school. So the claim is that the proportion at his high school is the same as the rest of the U.S., but he thinks that it's actually greater than the rest of the U.S. So the P that we're talking about here is the true proportion of college after high school at Bernard's school. Yes, the true value of the whole country is 69.7, but we're talking about it's probably that at this school, but he's hoping and thinking that it's more than that. So that's how we would write that. We have to make sure we're careful about our parameter. Do you guys have any questions about writing hypothesis statements?
No.
Easy, right? Sure. Why not? All right, cool. Let's continue then. Dun, 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 dun. All right, back to Coach Brooks. All right, yeah, so Coach Brooks, he claims to be an 80% free throw shooter. Let's go, Coach Brooks. We put him to the test one more time. We say, okay, come back another day. He does it one more time, and this is what we get. This time we give him 50 free throws, and he makes 32 of them. What is his sample proportion? 32 out of 50. What percent did he make if he made 32 out of 50? What percent is 32 out of 50?
64.
How'd you know that, Leonard? Because you didn't have a calculator.
Just double it.
Okay. For those of you who didn't catch what Leonard just said, 32 out of 50 is equivalent to 64 out of 100, so this would be 64%. Y'all follow me there? Okay. All right, cool. Can you plug it in a calculator? Of course you can. It's fine. All right, so he just made 64%. Do you think, based on this sample, that Coach Brooks is an 80% free throw shooter? He made 64% in this particular example. What do you think? Did he? Is he? Is he? I don't know. Is he? Let's go out. We can go ask him. Are you really? I don't know. All right, so here's the deal. He just gave us evidence, you guys. Okay? He claims to be 80%. He just gave us the evidence that we're going to use to evaluate his claim. We can say how strong the evidence is against his claim by giving the probability that an actual 80% free throw shooter would only hit 64% of their shots. Okay? So we're going to do this by a simulation. Obviously, we're not going to ask legit 80% free throw shooters to come shoot free throws, okay? So we're going to do like something called a simulation. You can see the picture here. Not there. Right there. All right, so here's the simulation. If someone is a true 80% free throw shooter, are they going to step up to the free throw line every single time and hit 80% of their shots? No, why not?
Sampling.
Sampling variability. Are you guys with me?
Yep.
Okay. So a true 80% free throw shooter is not going to hit 80% of their shots, correct? Correct. Okay, not all the time. Should they sometimes? Sure, of course. Okay, so are you shocked if an 80% free throw shooter only hits 68 or 78% of their shots? Are you shocked? Probably not. Are you shocked if an 80% free throw shooter hits 82% of their shots? Probably not. Okay, what about 76 or 84? Are you really shocked? Do you think that they're lying at that point? So, like, at what point do you think that this 80% free throw shooter is not really what they say they are? Okay? That's what this is doing. So, look, an 80% free throw shooter, can they sometimes hit, based on this simulation, can a real 80% free throw shooter sometimes hit 64%? Looks like it. Can an 80% free throw shooter sometime hit less than 64%? Well, look, there's two of them that hit 62%. So, there are 400 sets of 50 simulated free throws, and 3 times did an 80% free throw shooter in this simulation hit 64% or less of their free throws, okay? 3 times out of 400. So right here, the probability that Coach Brooks, who claims to be an 80% free throw shooter, the probability that he only hits 64% of his shots just because of sampling variability would be 3 out of 400, which is 0.0075. You guys, what's the chance that this difference is because of sampling variability? Less than a 1% chance. That means that there is a 99.25% chance that something else is going on. And what do you think that something else might be? There's only a 1% chance that this happened just by sampling variability, and he really is an 80% free throw shooter. But there's a 99% chance that what else could be happening?
Claim is false.
That he just ain't that good. That his claim is false. Very good. Okay, cool. So here it is. What does this mean in context of this situation? If Brooks is a true 80% shooter, there is only a 0.75% chance he made just 64% of his shots. That means there is a 99.25% chance that there is a different reason he missed so many. Likely, the claim is false. Dun, 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 dun. If Brooks is a true 80% free throw shooter, there is only a 0.75% chance that he made only 64% of his shots. That means that there's a 99.25% chance that there is a different reason that he missed so many, and that is likely that his claim is false. He ain't that good. What you guys have just witnessed is the number one thing that statisticians leave college having to understand. Is that right there. That is called the p-value. If you Google the number one most important concept in introductory statistics. It will be the p-value. What do you think the p stands for in p-value?
Parameter?
Nope. It's capital P, by the way. What does a capital P mean in this class?
Population, portion of.
Probability. Oh my. Also, we just talked about a probability, didn't we? All right, so the p-value is this right here. It is the probability that your sample is different because of sampling variability. That's what the p-value is. Okay. P-value. Oh, I skipped that. I said this, but I guess I'll write it down. There are only two possible explanations for the fact that he only made 64% of his free throws. The claim is false, or the claim is true, and he did what only happens 0.75% of the time for 80% free throw shooters. You guys, if you do something that happens less than 1% of the time, would you be surprised? Like if something happens to you that happens less than 1% of the time, you get hit by lightning. Are you shocked?
Yeah.
Yeah, literally shocked. That's pretty good. Thanks, Fabro. So, like, if something happens to you that happens less than 1% of the time, it might kind of make you go, I wonder if my claim was wrong. Like, this would probably have Coach Brooks reevaluating his free throw percentage because it happened less than 1% of the time. That is a p-value, okay? So, p-value is capital P, stands for probability. A p-value. P-value is the probability of getting a sample value as extreme or more extreme than the one observed, assuming the null hypothesis is true. We always assume the null hypothesis is true. It's like the justice system, right? I know that you guys probably don't believe this, but you're supposed to be innocent unless you are proven guilty. We assume that the null hypothesis is true unless we can prove it wrong. So it's kind of like how the justice system is, and then we have to go get evidence to try to prove this null hypothesis wrong. Sometimes we're going to be able to. Sometimes we're not, even if it's wrong. Okay? But that's the p-value. The p-value is the probability that we get a sample that is as extreme or more extreme than the one we observed, assuming that the null hypothesis was true. Cool? I guess we can be done. Are y'all ready to be done?
Yeah.
Okay, we'll be done. All right.